a couple introductory slides, and then it'll only take maybe 5 minutes or so. And then after that, we'll just go through, the plan is to just go through in order. If anyone has a need to present at a time different than the time they would naturally do it, you could kind of let me know in the chat, and we can move you. If you're not available right when your slot comes up, we can come back to you. But the overall plan would be just to go through them in order. I think that'll be easiest for everyone, and that way it's always easy to tell which one's next and how far through the agenda we are. So we're at the top of the hour, but I see several people are still joining. So we'll give it 2-3 minutes at least, and then and then we should be able to get started. I know for some of you it's quite late, and for others of you it's quite early the next day. So appreciate everyone being here. Okay, haven't seen anyone join in the last minute or so, and we're a few minutes past, so I think we'll go ahead and get started. The session is being recorded, so people who join late will always be able to catch the recording. Okay, so welcome back to, well, in this case, the closing session of the hackathon. Hopefully you had a good week, and this is our opportunity to share what we did. First of all, just a reminder of why we're here, really to advance the pace and relevance of IETF standards, and also to just put more focus on writing code, bringing in, and kind of helping developers in general contribute more to IETF, get more involved in IETF. Certainly writing code is important, and this event is, in addition to working on existing IETF drafts, also a big part of it is kind of introducing people into the IETF who might not be as familiar with it, but give them the ability to get involved, and in a way that's comfortable and very productive for them. And oftentimes that's through working on code more so than just reviewing the drafts and providing comments. So a reminder of the IETF note well, basically everything at the IETF, all IETF contributions fall under the terms of the note well. as we discussed in the opening, the code that you work on may have different license and rules around its use and what you need to do. But in terms of the presentations that you give here, those will be IETF contributions, and they fall under the terms of the note well. So if you haven't familiarized yourself with that, I suggest you do that. You know, we had really good participation for this. Last I checked, we had 268 people register. We had 24 projects. Looks like at least 15 of you are planning on presenting them. That's fantastic. Whether you're presenting your project or not, very important to upload it to the wiki. To the IETF Hackathon GitHub org. And there is a repo there for IETF109 project presentations. If you go to that, there are some instructions about how to do that. If you didn't get your presentation uploaded in time for the closing here, you're still free to share it from wherever you have it. Just make sure that you get it uploaded. And if you need to make changes after the presentation, you know, that's fine too. We just want to make sure that we capture the results, whether they were presented or not, and that they remain there for people to check out. And it's really a good reference for later on. Now, a reminder, these presentations are, they're to be short, just quick summaries about what you were trying to solve and what you achieved. And we really like to learn, like, not only what you did, but you know, what did you learn from it? And perhaps more importantly, in some cases, what did you find out or figure out that you would bring back to the working group in terms of if you were, for example, implementing a draft, what worked, what didn't, what was challenging. Any good feedback you'd be bringing back into your working group would be great to share here. And then hopefully you have the ability to share it during the working group session too. You have some agenda time. I know many of you have been doing that, and that's fantastic. Also, it's great to know when you worked with some people outside of the typical IETF community, perhaps getting involved with some open source project that's, you know, in another community, perhaps the Linux Foundation or with Apache or something like that. And you are working with folks from that community. That's good to know. Also, if you did a project that crossed, you know, IETF boundaries into work that another SDO is doing, that's really interesting to know as well. So with that, I will quickly switch back to the list of projects that are scheduled to present. And if you're wondering where that list is, you can go to the wiki, the Hackathon wiki, and use that and find it there. And I'll show you where it's at here. So here I am on just the Hackathon wiki. And if you go down into the agenda, you can see for the closing session, there's a link here to the results presentation schedule. And when I click on that, that has all the presentations that we're planning on having. And as I mentioned at the start, before maybe some of you joined, the plan is to just go through them in order. And so without any more delay, oh, and I see, wait, just let me see what's going on in the chat. Oh, thank you for pasting it in the chat. That was very helpful, Karsten. Glad you got to do that. Okay, so we'll start with performance evaluation for APN 6. I'll stop sharing. We can see your video, and if you request to share the screen, I'll grant that, and you can share your presentation. Don't hear your audio yet.
Hello, can you hear my voice?
There we go. Yep, we hear you now.
Oh, okay. Let me share my screen.
Okay.
Okay, can you see the presentation?
Yep, sure can.
Okay, let's start. So, hello everyone. My name is Wei Hong, and I'm from Beijing University for Posts and Telecommunications. The topic of my presentation is the performance evaluation of APN6. Well, at the last hackathon, we briefly introduced IFIT and APN6. The former is for telemetry, while the latter works for application-aware traffic control, and we also showed the implementation and simulation of them based on P4 and its software switch called BMV2. APN6 utilizes the IPv6 hop-by-hop option to indicate the application, the user, the flow, and so forth, and the option can also imply the requirement of quality. Here we show some related documents about APN6 and specifically the application-aware ID option, structure 1. This ID option includes 4 fields, namely SOA level, app ID, user ID, and flow ID. In this hackathon, we transplanted the demo of APN6 from BMV2 to a real P4 switch. The brand of the switch is 3DX, and its ASIC is the Barefoot Tofino. And then we tested the processing latency of encapsulating or inserting the application-aware ID option structure 1. Well, the implemented functions are shown in the slide. The functions contain the switching based on IPv6 DA, the determining whether to insert the ID option and the inserting of it. And finally is to get the processing latency. After we compiled the P4 program, we can get the MAU resource occupation directly. There are 2 processing about APN6, namely the determining and the inserting. The maximum number of the related entries is set to 1024. And the table shows the results. We can see all the mentioned resources are occupied less than 1.5%. There are 2 experiments to evaluate the processing latency. It's easy to understand. The experiment 1 has no any options encapsulated, while the experiment 2 has the ID option. We send 50,000 packs in total in each experiment and get the results. And all the results are shown in nanoseconds. From this table, we can see the difference between the average processing latency of these experiments are about only 6.6 nanoseconds. This difference is caused by the processing of APN6. And then we simply analyzed the results. We firstly used the KS test to prove that they are both in accordance with the normal distribution. After that, we calculated some probabilities. The results are shown in these 2 tables. For example, if we got 10,000 packets, the probability of that their average latency increasing is less than 1.80% is about 1%. But if we see the average increasing is less than 1.82%, the probability is 100%. If we get 1 packet, the probability of that is latency increasing is less than 1.80% is about 50%. And if we assume the increasing is 2%, the probability is 88%. We can draw a conclusion that about the encapsulating of APN6 ID option, its latency overhead is 1.81% at the macro level and 2.4% at the micro. And in the future, we will deploy the P4 switch on CNI and test IFIT and APN6 on it. CNI is a cross-domain experimental network which allows us to do some better experiments. And finally, if you have some puzzles or interests, don't hesitate to contact us. And that's all. Thanks for listening.
Okay, well, thank you very much. Okay, so next up, Yang Mediator Framework. Okay.
Can you hear me?
I believe so. Can you say something again? It was a little faint.
Oh, hi, Charles. Can you hear my voice?
Yeah, it's a little faint though.
A little thing? Okay. I will come closer to the phone. Okay, let me share my screen.
Okay.
Okay.
Great. We see your slides.
Okay. Hello, everyone. My name is Liu Yongbo. I am a PhD student from Southeast University in China. For this hackathon, our team's project is Mediator Framework Project. Mediator is a framework for the third developer to implement young model conversion. Here are some links of the relevant drafts of our project. Mediator offers support for the translation of young models from different vendors or standard organizations. For Mediator, there are 3 ways of deployment. First is independent. Second, it can be integrated with controller or integrated with devices. The picture on the right shows the ways of independent deployment with which Mediator will be deployed as an independent network node. Our current implementation is based on the scenario of 4G access. This task is to configure BGP and VPN for devices. It involves a conversion between IETF YAM and vendors YAM. The main workflow of our demo is looked like in the picture on the right. The Ansible we use as a controller will connect to Mediator with a plugin, and the Mediator will translate the message and return it back to Ansible. The Ansible will send the translated configuration to the devices. Here are the sample messages we intercepted from the project. The input is a message instantiated from IETF L3NM model. Our goal is to generate the output that is correspond to the vendor's network instance model. For now, we have developed Mediator framework which provide Python API, and for this project we developed translation scripts between IETF L3NM model and vendor native YAM. And to integrate it with Ansible, we developed a plugin. And last, we have successfully delivered the configuration which instantiated from the IETF model to the vendor devices using Mediator. Compared to the traditional ways of scripts developing, there are several advantages of Mediator. The Python API Mediator offers minimize the barrier for developing, and Mediator also can offer support for complex scenarios of message conversion. And Mediator can offer a script template will help developing. And the plugin can help Mediator to integrate with different kinds of controllers. And the last, Mediator is coupled from the network management protocol, which have enable a flexible deployment. From this hackathon, we learned that current ways of developing translation scripts are inefficient. So the goal of our project is make it easier and faster for the developing. So in the future, we will continue working on this project. We intend to implement automatic scripts generation, and also we will do more tests with different service provider. And here's our team member. Here are the links of our open source project and the demo video. If you are interested, you can pay them a visit or contact us via email. That's all. Thank you.
Okay. Well, great. Thank you. Thank you very much.
Okay.
Next up, RAT's EAT implementation. Yeah, so we don't see your presentation yet. I can see your video, but I don't think we hear you either. So you have to unmute your audio. Looks like it's still muted. Do you see the icon to mute or unmute your audio? It seems like it flashes on for a second and then it goes away. Also, the screen share had started, but then it seemed like it stopped. Maybe it's a matter of the browser not being granted permissions. Okay, I think we will come back to Thomas. Why don't we move on to DNS now?
Okay, let me check if I can.
We have your audio and your video. And now we're just waiting. Looks like the screen share is starting up.
Okay.
There we go. We can see it.
Okay. So these are the results from the Dns Hackathon Project. So we DNS people, we have normally I would go to the hackathon room and see all my fellow DNS people there, and then start and decide on what kind of features we are going to implement. And I could have used the Gather Town, but we DNS people also have this organization on which most people's DNS people are a member of, which is the DNS org, the DNS Operations and Analysis Research Center. And they have this MetaMost chat service, which I used to ask if other people would like to join the IETF 109 hackathon for working on DNS projects. So 14 signed up, but most of them also had to work as usual during this week. And so they did not have dedicated time to work on the projects like we would normally have in a in-person hackathon. So there was not as much done as we don't have as many projects to present as in an in-person hackathon. That said, we worked on one hack which is interesting, which is Draft Arendt's DNS error reporting. This saw the most work, I think. It's the draft is about error reporting, things that go wrong on an authoritative server or with DNS records. And instead of informing the requester of the resource record about the error is sent to the authoritative server, which hosts the broken record. So, which makes sense, right? Because then the maintainer of that zone can do something about it. And so the chat server worked quite well. We immediately, Roy solicited or asked about broken DNS zones. So we could have some sort of testing environment, and suggestions were offered on the chat servers. A implementation of a authoritative server that would return the option on where to report the or file the report about brokenness of a name was created, and also a test server that would show the reports that came in about broken DNS records. And so that's was done. So there's another side. You also need resolvers that send the eDNS option to the authoritative, saying I'm willing to report errors to the report server. But although many of the resolver implementations already have the extended DNS errors, we did not have a implementation yet which reported to a specific reporting server. But there was in the chat, there was other interesting discussion on what that would entail, if it would work in practice, and also on how we could measure if this would work in practice. So another hack that was done is the Dns Zone Dig Digest. It's, you know, the DNSSEC provides integrity and authenticity for RR sets, for complete RR sets. ZoneMD provides integrity and authenticity for complete zones. So a secondary authoritative server can be sure that it serves the complete zone. There used to be a proof of concept tool written by the artists of the draft, but it was a bit cumbersome to use, and during the hackathon, a new option was introduced in LDNS sign zone to provide a zone MD resource record to a zone without much hassle. Finally, a lot of people were planning to work on the new catalog zones draft and test or do interoperability testing, but we didn't get to this. We were too much busy with communicating and interacting about the first hack, I think. But a lot of people mentioned that they still intend to work on this over the weekend and then do a report of DNS catalog zones interoperability testing at the DNS Op Working Group session. So what we've learned is that it's really missed the in-person hackathon, because you know, it's better to have ad hoc conversations and social interaction in person than and also to have all the people dedicated on working on the hacks. But it worked out quite well, I think, the way we did it. We still had implementers focus on new IDs and standards, and we had valuable input, I think, during this week, which we might otherwise would have taken more time, or at least we had the focused implementers perspective on these new IDs and standards, which is very valuable. So I requested to do a report of this hackathon during the DNS Op on Friday, which will give us some more time to finish some of the hacks. 14 people joined the MetaMost service, which was, by the way, also public for other members, or for anyone, basically, which I mentioned on the hackathon wiki page. That's it.
Okay, well, that's great, and certainly it's perfectly fine and encouraged to continue to work on these things outside of the week of the hackathon. So glad you're planning on doing that, and yeah, if you want to update or add to the report you have on the uploaded to GitHub, that'd be great.
Sure, I'll do that.
Okay, and Dominique, I see you're asking, yep, LP WAN's next, thank you. We'll switch over to you. So we see your screen share, but we also need your audio and video. Okay, there we go. Or at least your audio.
Can you hear the audio?
Yeah, I can hear your audio now.
Okay, I'm going to show the video briefly to show that I'm real. Hi, and then I turn it off to save bandwidth on the audio.
Okay. Yes, it is. It's maybe perhaps a little choppy at times, but did seem to be working.
Okay, let's try. I won't move my cursor too much on the screen so that I save bandwidth for the audio. Okay, hi everybody. This is a report of the LP1 project. We work for the LP1 working group, obviously. It was our plan for the hackathon, as in all the previous check the header compression and fragmentation technology being developed at the LP1 working group, which has been standardized as RFC 8724 last April. And as usual, we want to improve the existing code base, do some cleanup, implement some options, details that are not in there yet, and also improve the documentation so we make it easier for people to use the open source code that we provide. And also, as I'm going to show in the next slide, develop connectors so that we can use that compression technology over existing networks such as LoRaWAN or Sigfox or NB-IoT more easily. And also this time we wanted to implement a few features of a draft that we have at the LP1 working group. It's still work in progress. It's not even adopted by the working group yet, but it's one of the extensions that we want to specify on top of RFC 8724. And also we want to, if you implement it, commercial or academic, and we want to make sure we can do some interrupt testing between them going forward. So we did this time, so I'm not expecting you to read the fine prints on the block diagram, but what we have to the right is the end device that runs on an embedded microcontroller, and to glue this application, reading from right to left, application on top of the compression fragmentation layer. Then the device sends the payload on the LP1 network, and then typically we have a gateway in the LP1 network that exposes a REST interface to the internet. And so what we SHIC code on top of existing LP1 networks, commercial or experimental, that have this network server with a REST interface to the internet. So that's one thing that got done, and the other one was implementing a few of the features of the draft I just mentioned before, which relate to pings and ICMPv6 error messages. And so like if you get a ping from the internet to the device that's IPv6 enabled through the use of SHIC, you probably don't want to forward the ping over the LP1, which is severely energy constrained and time on air constrained. So the SHIC layer at the network server will act as a proxy and probably respond with a reply based on previous communications with the end device. Just to give you a slight idea of what we want to do. And we also did some documentation cleanup. Now we have a user guide that's actually usable, which is better than it was before, because we had evolved the code, and the user guide didn't match that. And so what we learned, we loved using gather.town. It worked great. Again, even better than last time. We had the whiteboard that we used to compare notes, what's working, what's not, what do we do next. Work for the morning meeting, get the day work started, or so overall, I think we not available this week, but anyway, and yeah, you see happy faces. So we're very happy with how it went and how we advanced the work. That's it for me.
Great. Thanks a lot for that. And it was encouraging to see that and hear that the Gather worked well for you. I'm glad it did. I did notice quite a few people using it throughout the course of the hackathon. So hopefully that continues to improve and be more and more useful for us. Okay, next up we have quick measurements. We see your audio. We don't have a...
Hello? Can you hear me?
Yes, now I can hear you and see you.
Okay, thank you. I forgot to unmute the audio. Okay, I share my screen.
Okay, I just granted you access.
Okay. Okay. I'm Fabio Bulgarella from Telecom Italia and part of the quick measurement team. In this hackathon, our goals were to provide tools and ideas for traffic performance monitoring, especially considering the era of the new encrypted transport protocol that are growing. And these tools and ideas use the explicit flow measurement techniques that are some techniques that employ few marking bits inside the header of each packet. And these are done for expose some information on the network about loss and delay, and this way we can measure traffic. Another goal was to update the spin dump tool, that is the tool developed by the Ericsson guys, that is really useful because can intercept a lot of kind of traffic, ICMP, TCP, QUIC, SCTP, and other stuff. What got done? We tried to expose a new idea. This new idea is to give the monitoring power to customers, so make the customer choose if they want or not share the information about the traffic. We presented an Android explicit monitoring app that is based on SpinDump. ThinQuick is its name. And we did also a POC live demo of the application during this hackathon. The two drafts involved in this project are the MDT explicit flow measurement and the user device explicit monitoring. Also, we did also some spin dump maintenance. For example, we fixed some problem on the TCP RTT computation, and we added the support for the last quick version. These are some slides about the application. As you can see, with this application, we can intercept all the traffic flowing in and out from an Android mobile phone. We can track the application, we can track the connection, and try to compute some information from the data that are exposed on wire. These are real-time mobile traffic monitoring, and what we noticed was that placing the explicit performance observer on user device gives many advantages in terms of scalability, of course, hardware deployment, and also measures precisions. So we noticed that measurements are more precise in the client because we can remove the application delay of the client side and make the measurements more precise. These are another slide that that gives an image of the application working during a YouTube transmission. As you can see, there's there are some information about the connection. In this case, we can see the round trip time measured in a quick connection. In this case, is only the one computed exploiting the quick handshake packets. In fact, you can see there's no spin bit activated in this connection. And what we think is that operators with a customer's permission could use this information to promptly identify network problems and try to improve their overall the overall customer experience. And other things could be to improve also the network, being able to locate that part of network, the area, for example, in mobile. Speaking of mobile network, that area that are not covered well. These are the teams members that took part during this hackathon. There are some guys from Ericsson, from Huawei, and some other guys like me from Telecom Italia. There's also the GitHub of Spindamp that you can see to take all the information about the software used to make this app working. Thank you.
Okay, great. Thank you, Fabio. Okay, next up we have Karsten. And ASDF. All right, we can see your presentation. No video is okay, but we need your audio. And you should just be able to unmute yourself.
Okay, better?
There we go. Yep, great. It's all yours.
Okay. Yeah, I didn't know that after you unmuted me, I needed to unmute myself as well. Good morning. I'm sorry, but 6 a.m. means no video for me. I don't want to scare you. This team is the ASDF team, getting ready for SDF 1.1. And ASDF is a new working group that was just formed based on the observation that data models for IoT things are very different without a need actually for this difference. Nobody gains from that difference. About 2 years ago, a group of people came together from different standards organizations and created a liaison organization called One Data Model. And they worked on setting up processes to actually get the various SDOs to converge their data model, so that the Bluetooth data model doesn't look that much different from an OCF or an OMA data model, and everybody agrees on what a refrigerator or thermostat or anything like that is going to look like. And in that process, of course, the need for a common modeling format came up. And in June, a 1.0 version of such a modeling format was agreed within One Data Model. And then One Data Model decided they really wanted the IETF to complete the specification of this specification language. We did get a new working group set up. And now we are working on 1.1. And the idea is that we don't just update the specification language on paper, but we actually try it out. So this is what this hackathon was about. And the idea was to go through the open issues that we had on SDF 1.0 and write code that exercises the changes that are proposed. And in the process, make sure that the about 200 models, the SDF specs that we have, actually can be updated along these changes. So we don't just want to agree on a change and then later notice, oh, this is hard to implement. We want to have them implemented before agreeing on them. And as a little side activity, we had a look at Jana's Yang to SDF conversion tool. Unfortunately, we didn't quite spend enough time on that, but I think at least people got introduced to that, and we will probably pick this up later a bit. So what did we manage to do? We have 4 major issues on SDF 1.0. And we managed to get work done on 2 of them. So we are pretty much sure that we have the cross-model referencing nailed now. We came up with a convention on the usage of queries for those cross-model references, and discussed how models transition their namespaces while they progress through the process. On the issue of aggregation or compound types, we actually found that we can kind of simplify STF 1.0 while putting in this aggregation, and we tried that out, and it looks good. Now we just have to finish the aggregation discussion, and we probably can do this in the working group meeting next week. So we will still have work to be done today. So we will meet in the afternoon, European afternoon, today, and try to wrap up that work. What we learned, we organized ourselves into a daily 1-hour meeting at a time where most people are awake, and did all the code writing and spec bashing in between those 1-hour meetings. So we didn't set up additional conference. We just did our homework and sent a few mail messages, and then met again for this 1-hour slot. Our main tool, of course, is Git and GitHub. CodiMD turned out to be really useful, and thanks for the IETF CodiMD instance. That was our main collaboration tool, and we did use WebEx with the usual problems of blank slides and all that. So this is the team. We had a small team with 2 IETF first-timers, and you can find more at 1dm.org, which is the SDO that kind of kicked, or it's not an SDO, the liaison organization between SDOs that kicked off this work, and our GitHub, our working group GitHub repository, where the issues are that we worked on.
Okay, well, fantastic. Seems like ASDF is off to a great start.
I think so.
Nice to have a hackathon at your first, because this is the first IETF meeting. I think that working group, that working group just started, as you mentioned, so that's
yes.
Okay, well, thank you, Carsten. All right, rough time, implementing version 3. Okay.
All right.
Yep,
Let me see if I start a slideshow, if it still shows up. Not shout.
There you go.
Our hackathon plan was to implement rough time. There's implementations kicking around of earlier versions, but I wanted to update at least 2 to, or at least mine and someone else to update theirs to draft IETF NTP rough time -03. Rough time, if you're not familiar, is essentially certificate transparency for time. So in applications where you don't necessarily have a good source of time and want valid signatures, designed to get a close enough time with high security guarantees to enable that. What got done? Well, we didn't really have a sort of get together and work synchronously on it, but I was able to set up a server on a branch of Cloudflare's where I work's repository, stand it up, and Jonathan Lindquist wrote a client, and we interoperated successfully. So apparently the spec is clear enough for people to sit down and make it work, hopefully without too much poking at an existing implementation. So that's a pretty good sign that the draft is maturing. And we learned quite a bit. So I run FreeBSD on the server I put the thing on, and I learned that the timing interfaces that we need, because rough time depends on monotonicity, you need to know the leap second. And this is not supported in POSIX, so we need an extension, and they're different. And so we got to deal with that issue. Also, there was some confusion about the modified Julian date plus microsecond since midnight representation we use in since noon. No, midnight. One of the two. I'll look it up. That we use. It's somewhat unusual as a time format. VMS fans might be happier with it. And what's very interesting about it is it's non-unique. There are certain seconds that have multiple representations, and it's not always valid because days don't always have the same length in the number of SI seconds. And so these are things that libraries need to think about. And so there's work that needs to be done to get routines there that are tested and work well.
Okay, well, great. Thank you for the presentation. Next up, we have BGP monitoring protocol and Yang push. And I've granted you the screen. Great, we see your video. Make sure you enable your audio as well. All right.
Perfect. Okay. Then you see my screen?
Yep. Your yeah, we can see it. Your audio sounds a little faint.
Okay, then
That's
a bit
good.
closer. Okay,
Yep.
Excellent. So I'm Thomas from Swisscom, representing the BMP and Young project. This time on BMP, we're working on mainly on the path marking and the route policy attribute tracing drafts, how they work together with the BMP local RIP, but also we had some extensions on IPFix to get the BGP route distinguisher and use that as well for the BMP log RIP to IPFix forwarding plane correlation. Besides that, we want to look at the performance impact on BMP, on CPU, on memory, on the route processors, and monitor them with Yang push. On the Yang push part, we started with the UDP notif and the distributed notif implementation. So this is basically a very lightweight way of collecting Yang metrics from a router, especially with the aim to directly expose the metrics from network processors on line card, with the focus on accounting data. This is the software.
I see you advanced slides. I don't know if you are.
I'm sorry.
We're still seeing your just the first slide, or
okay. That's okay. Then I will try to reshare.
You can put it in presentation mode.
Oh, I see. I see. So then let me just go back and I will try share again. I'm sorry for that. Can you see the slide now?
It looks like it's starting up. Just wait a minute.
Sure. Sorry, now. So now it should work. So you should see the second page.
Yes.
On the slide. Okay,
Yep.
Great. So these were the BMP drafts. These for the Yang push part. And These are the open source software which we're using for our test environment. This is our network topology with the data collection, the BGP, and the traffic generators, the MPLS VPN network. This time we added also other vendors into the network, mainly Cisco IOS XR XE, Juniper Junos, and FR routing for IPFix and BMP. And we were working also on the basically through netconf get schema to get the entire recursive schema, including the imports, convert them to JSON and register them in the schema registry. And what we learned from the lab environment is that in order then for the next step, when we do the stress tests with BMP to see wherever the back pressure mechanism within the BGP BMP process is working, we need to increase our scale in the data ingestion at the time series database. So in order to make sure that we are able to, especially in these high peaks, that we are able to grab the data within a very short period of time. On the data collection on PMACCT side, the decoding on route policy attribute tracing continued. We were working on path marking, and also the IPFix correlation now supports also the IE19, the route distinguisher attribute. The UDP notif has been included in PMACCT now. It should be this upcoming 1 or 2 weeks being pushed to GitHub. This is an example of route policy attribute tracing. So here you can see for on a MPLS PE router for a given prefix, basically in which VRF, which route policy at which attachment point this prefix was traversing to. This is the IPFix to BMP loclip correlation now with the IE90 attribute on IPFix. At Huawei VRP, the support, the BMP support was updated to the latest path marking and route policy attribute tracing drafts, and also now supporting the new UDP notif header for young push. We were performing the stress tests with 100,000, 500,000, and 1 million BGP VPN v4 unicast prefixes. And here just some example. This is basically the CPU usage from the two test sets with 100,000 and 500,000 routes. And above you see when before BMP was enabled, below when BMP is enabled, and as expected, since the routes need now to be additionally exposed to the BMP collector, the CPU usage is increasing. And in the memory, as expected, through the back pressure mechanism between BGP and BMP, the memory impact is very minor. We're using Wireshark dissectors to basically troubleshoot the data collection. So thanks to Alexis and Uli, who has been working on the implementations of the UDP notif and the BMP path marking dissectors, we were able to use them during our hackathon, and we are still currently working on that and validating them. What we've learned is it's our 4th hackathon, so team collaboration is getting better by the hackathon. We have good spirits. Slack helped a lot to keep connected through the different time zones, but yet again, no beers and cocktails after. Thanks. Oh, wait. And yeah, this time we had also some students on board from INSA, Tom and Axel from Swisscom, Marco, and also Kian from Zeng. Thanks a lot. Okay.
Well, yeah, thank you for that. I too missed many aspects of the in-person hackathon, but I'm glad you and others are finding this online format, at least a useful substitute. Okay, so next up, IPv6, IOAM. Justin, actually don't see Justin. Anyone else from that team here to present? Unless I'm just missing him, I don't see Justin, or if maybe he's one of the undefined people. Okay, Justin, if you're here, either unmute your mic or share your screen or raise your hand or something. Otherwise, we're going to move forward. I'll just make a note of that and we'll come back to that one. Oh, there. And Tom Henderson, yep, great. We'll move on to yours.
Am I audible?
Yes, you are.
Okay.
Your screen share isn't quite right for us yet. We're seeing, okay, there you go.
All right. Okay, I'm Tom Henderson. I'm with the NS3 project, which is a discrete event network simulator. And we started to participate in the IETF hackathons for the last few sessions. We've been focusing on NS3 models for the L4S architecture, which is being developed in the transport area working group. But for this hackathon, we focused more on a few other TCP related models, including our cubic model, BBR-V1, and a network testing tool known as FLENS. And in general, what we were focusing on at this hackathon was alignments of some of our NS3 models with Linux implementations and running the code either on test beds or in software frameworks used to exercise the Linux code. So on this slide, it just notes a few of the RFCs that were involved in these models. The specific things that our team sought to work on this week was that we were missing support for ECN marking in our cubic model and overall alignment with how the Linux implementation performs in that regard. We have a BBR-V1 model that we've been working on. A team of students at NITK Sarathkal was working on aligning this with Linux testbed results. And then we also have been trying to line up what we've observed as results from using the Flint traffic tool on test beds with a version of Flint that we have also for NS3. And so just to summarize, we had a team of 5 people working. We did implement a new state in our TCP socket model that implements the congestion window reduced and fast recovery phase due to ECN marking that's experienced in the network, and achieve pretty good alignment with the Linux implementation. And the URL to that, all of our code trees is listed on this slide. We got good alignment with our BBR model with testbed results from Linux. And we made some progress figuring out some discrepancies that existed in our NS3 FLENS RUL test suite compared to what we were observing on large bandwidth delay product links when we used Linux testbeds for comparison. Lessons learned. Well, I guess one of the interesting things is that in the past week, the TCP/M and ICCRG groups have picked up some discussion on possibly revising Cubic, the RFC, and that RFC actually is missing information about how to respond to ECN marking. So that might be a piece of feedback that we could deliver to the working group, and we'll try to follow up on that. And then finally, these are the 5 people who participated, and we had 3 newcomers this time.
Okay, that's great. Yeah, thank you. And good luck with following up within the working group. I hope that goes well. Okay, next up, Paul, I guess you have a couple presentations, I2NSF and also IPWave.
Hello, Charles, can you hear me?
Yes, I can.
Okay, good. Okay, great. Hello, my name is Jeon Jung from SKKU. So this time, as you can see, my team get together in some conference room, and we're working for. Oh, screen is not.
Not yet. We don't see your screen. It says it's being shared, but it hasn't popped up yet.
Okay.
Is it asking you for permission, perhaps?
Okay. So how can I share the screen? This one? Oh, this one. Okay. Okay. Share the screen. Okay. Here you go. Okay. Okay. You can see my screen, right? Okay. Great.
There we go. That looks good.
Okay. Okay. Great. So my team is I2NSF Framework Project. My name is Jeon Jung from SKKU. This is the poster. So we have 2 professors, 2 researchers from H3, and also we have 5 students, SKKU, Liberty University in United States, and also Sungsil University and Kenya, Kyungbuk National University. So basically, this time, our I2NSF working group tried to extend the framework for security management automation. So basically, we have I2NSF user for the dashboard deliver high-level policy, and also security controller translate the policy into low-level policy in security services on top of network security functions such as firewall, web filter, etc. This time, we implemented the I2NSF analyzer to monitor the activity of NSF. Also, we detect security attack. So we implemented a monitoring interface using lastconf, and then we collect monitoring data such as CPU usages and also disk usage, and also traffic incoming, outgoing statistics gathered. So I2NSF analyzer will analyze for that kind of activity. So we have 4 interfaces. Previously, we implemented also we showed the proof of concept, restoration, consumer facing, and NSF face interfaces. This time, we implemented the monitoring interface. Okay, so we implemented 2 draft. Additionally, NSF monitoring data model, also security management automation for I2NSF data analysis. So this is the network topology. So we added a new component analyzer. So right-hand side shows open sources and also minimum spec for OpenStack. So what got done? So we established I2NSF framework. In addition to that, we implemented the NSF monitoring interface to measure the performance of CPU, memory, disk interfaces. This is our component left-hand side, this one is a web-based I2NSF user specify time-based web filter. Right side, security controller and the data developers management system, DMS. So basically, this hackathon, you can see we specify the data type such as traffic from interface. Also, we asked system resources, CPU, disk, memory, so we can get that monitor data over JSON over REST conf. Okay. So what we learned, we realized the feasibility of NSF monitoring via REST conf or netconf for security management. Next time, we'll continue to support monitoring interface using netconf. Also, we will enhance security policy translator for automatic setting and mapping between high-level YANG model and low-level YANG model. And finally, we also implement a new interface, such as application interface from analyzer to security controller to enforce new security policy or augmentation of security policy. Okay. This is open source project GitHub. This is a video demonstration. So this 1 week, my student and other collaborator from H3 and also Sungsil University, Gyeongbuk National University student, we gathered and we worked together and we make it. Okay, thank you for your attention. Okay, that's it. Thank you, Charles. So Charles, next, yeah, can you hear me? Oh, what's going on? Chris, yeah, there is no sound.
Yeah.
He didn't talk.
He did not turn on.
Oh, he didn't. Okay, Charles, your microphone looks like muted.
I guess I was muted, didn't realize it. Okay, yeah, thank you very much. So that covered both.
No, may I continue IP wave? Yeah.
Yeah, go right ahead.
Okay, okay, sure.
We don't hear or see you right now.
Okay, can you hear me?
Okay, there we go. Yep.
Okay, good. Camera, okay, camera. Okay, camera also enabled, okay?
Yeah, we got both now, perfect.
Okay, thank you, yeah. So this project is about IP wave basic protocols project. So I'm champion from SKKU. So this is the poster for this project. We have two professors, me and Professor Young-Han Kim from Sungsil University, and also we have 3 universities: SKKU student and Sungsil University and Gyeongbuk National University students. Okay. So this is student project. So previously, we demonstrated IP wave basic protocols. IETF109 Hackathon Project last year in Singapore, we demonstrated the IP version 6 packet transmission over to OCB-enabled Wi-Fi modules in vehicular networks. Last summer, IETF109 Hackathon Project, we showed the simulation of a context-aware navigation protocol for road crash avoidance. This time, we tried to implement context-aware navigation protocol using Wi-Fi OCB mode. So this hackathon, we tried to support context-aware navigation protocol over IP wave. This is the draft. So right-hand side, you can see currently we are trying to implement Linux extension for IPv6 neighbor discovery for the robot Ubuntu Linux kernel. So this model is Ion Robotics Aron. Right now we doesn't support the movement of robot, but next month we try to enable our code on top of this robot. So basically, a context-aware navigation protocol case, you can see this is a highway scenario. Some vehicle hit some obstacle, and following vehicle observed, and then this V1 detected this dangerous situation and disseminate this emergency context message to neighbor vehicles. So basically, IP wave context-aware navigation protocol, we using IPv6 neighbor discovery messages to contain copulation context message and emergency context message for driving condition. So this is the message format for vehicle mobility information option, one of neighbor discovery option in IPv6. So it supports CCM, ECM. ECM is emergency context message or copulation message. So we set up environment using 2 laptops, having Ubuntu Linux. Also, we use the SRS Wi-Fi, the module for L2.11 OCB mode. Okay. So this time we try to implement the neighbor discovery for context-aware navigation protocol, but there was some problem and issues. So we fixed some compiling issue, but we tried to implement the generation of vehicle mobility information option, also deliver and process at receiver side. So next time hackathon, we try to demonstrate on top of robot car for context-aware navigator protocol. So this is an open source project. We continue making our IP wave based context-aware navigation protocol. So I think next month our community can access this website to get our implementation. So this is our teamwork. So in the same way, we work this week in the conference room. So left-hand side, the participant and team members, and we work together with the I2NSF and BMWG teams. Thank you for your attention. Okay, thank you, Charles. Yeah.
Great, thank you, Paul, for both presentations. And glad you already have some ideas about what you want to do for the next hackathon. That's
okay. Thank you.
Good to know. Okay, next up we have Mud.
Can you all hear me?
Sure can.
Awesome. Let's see if we can get my screen to display.
There we go.
Yes, I want to share it. Okay. All right. Oh, went black. All right. Can everyone see everything?
It tells us you're starting, but we don't see it yet.
Oh, there we go. I see. Okay. Share. do that. All right.
Okay.
Very good.
Great.
All right. So hi, everyone. I'm Paul Wotropski. I'm representing the MUD group here. So the project we worked on was titled MUD PD, and such. It'll make a little more sense in a second. So MUD is the manufacturer usage description. It's RFC 8520. And MUD essentially focuses on device intent, creating allow lists, defining what hosts can communicate with the device through defined protocols and ports. So the primary goal here was to work on MUD PD which aims to assist in building the files that are needed to conform to that MUD specification. So our plan was to get some feedback and usability on the usability and to identify some bugs for the MUD PD tool. We also were aiming to integrate Muddy, which is a Python command line tool to help with formatting MUD files. So we wanted to integrate Muddy into MUD PD itself. And we wanted to add some updates to MUD PD tool to improve the usability from the feedback that we would get. So what we got done was that we actually identified a bug with the current MUD file generation wizard, which is probably the best place to find a bug since we're already working to replace that current MUD file generation wizard. So we're actually replacing that with Muddy, which was actually a tool that was developed at the IETF109 hackathon, based on a tool that was created before that. So we also ended up discussing an option field in the PCAP-NG file format. This was primarily to see if we can provide machine-readable contextual information about the MUD file itself, or sorry, about the packet capture itself. Because right now we had planned to embed, basically embedding JSON into the comment field. So we were looking for a more elegant solution than that. And then we developed a bunch of new code, which can be found at the GitHub there, the USNIST gov MUD PD project there. So to wrap things up, these were the members of the team this hackathon. We definitely kind of wish we could have been there, been all together in person. It definitely helps with having the ad hoc conversations and discussions and figuring out bugs just hands-on versus trying to remotely solve issues. So that's MUD PD. Thank you.
Okay. Well, thanks for that. I'm glad you guys were able to get some stuff done, even if it wasn't optimal setup for it. Okay, BMWG.
근 소리가 안 나와요?
Well,
Can you hear my?
Yes. Okay, perfect. Yep, I can see your screen too.
Hello, I'm Hyun-Shin Yang in Internet Infra System Research Center in the South Korea. Today I will present about the result of the Hackathon 109 about the containerized infrastructure benchmarking. So basically, our goal is that what kinds of resource are packed to the containers networking. So we have the one draft. You can see our draft with this link, and we have the two core of the draft. First one is hackathon. The first one is implementing real container infrastructure with the various network model, and second one is verifying the performance based on our draft. So last time we also joined 1 year ago. So we joined the IETF Hackathon 106 at Singapore, and at that time we tested networking performance with the DPDK and the Conti VPP. So and then one of the goal of the back then is figure out the speed scheduler really packed to the networking performance or not. So you can see the result with our draft. At this time, we we also make the test bed with SRIB and DPDK. You're also one of the user space model, but it's a pass-through model. So according to our draft, we mentioned that the huge page will be opaque to the networking performance. So we want to figure out the relationship between correlation between the huge page with and the networking performance with the space-based model. So in this hackathon we set up our test bed like this. So we use a 3 server. The one is for the master, and another one is for the worker node for the container, and the last one is for the packet generator. So we use the T-Rex generator to make the packet and E4 to the worker node and get back the packet and figure out the performance at the T-Rex generator. So we follow this data path, and we modify the huge pages and test the networking performance with an SRIB DPDK networking architectures. So in this hackathon, we got the graph. We think that the huge page does not affect to the networking performance because basically when you test it, the maximum size of the MTU is 1,518. So I think is enough for the huge pages, but we need more testing to figure out the relationship between the application and the huge pages too. And we also got the many errors because of the memory and the huge page setup, because it's really bit complicated. So it's not easy to change several times. So it's also one of our reasons. And next hackathon, we will try to figure out the networking model, the corner-based networking models such as eBPF. And we also, until now, we tested with north-south traffic, but next time we are trying to use east-west traffic pattern and test with the content networking model. So this is our team. So thank you for listening.
Okay, fantastic. Thank you very much. Okay, well, so now we have 2 presentations that we skipped over, and I know the one for rats. Why don't we go back to that one?
Hi, Charles, can you hear me?
Yes, I can hear you.
Can you see me?
And now I can see you.
It must be a horrible view, but anyway. Okay, let's...
Now we just, okay. And I see you're asking to show, oh, there it is. Okay, got it.
Can you see it, the slides?
Yes, I can. Perfect.
Okay, cool. So what was our plan? The plan was to implement EAT, the entity attestation token, which has now reached 0.4. I wanted to check the state of the spec in terms of implementability. What was missing, what needs fixing, etc. And the attack strategy was a 50-50 split via attestation claim between me and Sergey. So we go in parallel in code and test, and then we get together to review the code, we merge the code, and then iterate. And that's very convenient because these attestation claims are basically pieces of CDDL that you can really implement in isolation and then have an integration point, which is convenient at a later point in time. What got done is a full implementation of the draft in 17 PRs and around 2,400 lines of Go code, including 52 tests, which are table-driven, so the test cases that are much more than that. And implementation is on GitHub at the URL that you can see. There is on it. Apart from coding, like Matt, we had some design discussion around the API ergonomics for dealing with IP profiles. That is things that expand the semantics of EAT, of the EAT format. And we started some discussion around that, and we discussing it in the open and on GitHub. So if you want to participate in the discussion, there you go. There was no interrupt this time because the only other implementation that we know of it was not around. And the demo is this fantastic screenshot from my laptop, which shows the test being run again against the code base, showing a fantastic 84.8 coverage. It's not great, but anyway. What we learned is that the draft in its form is actually implementable without too much pain. So it's sort of mature. And we provided some feedback to the draft authors and the wider RATS working group in form of an email, which was the hackathon report. And here you are the link. And wrapping up, okay, so the team this time was minuscule. It was Sergey and I, and Sergey was a first-timer. And the project which we're doing this implementation is the Verizon project, which is an open source project. That, the intent is to provide attestation verification components that one can assemble to build a complete attestation verifier. And the verifier is one fundamental role in the RATS architecture. Logically, we're starting from the grounds up, building the building blocks at this time. And this includes other standards and SDOs. Apart from the IETF, we're crossing the TCG and ISO boundaries here. And we started with EAT. Actually, we started with COSWID a week ago. And that was also a good way to provide feedback to the COSWID authors and the SACM working group. And nothing. If you're interested in attestation, please go to the Verizon page and look for the presentation material there. And another thing is that we want to make this the first of a series of hackathon to be used as a sync point for the Verizon project. So if you're interested, next time we can organize a bigger table and bring your own ideas and whatnot. I think that's it. Thank you, and sorry for before.
Thank you for your presentation. Glad we got things sorted out.
Cheers.
Okay, so we also skipped over Justin, who I received an email from Justin. I know he was having some network difficulty. Justin, I don't see you, so I don't think you were able to make it back. Is there anyone else here on behalf of Justin who would be able to present the IPv6 IOAM? Okay, if not, just encourage people to take a look at the presentation that he's uploaded. With that, let's see. So just a couple more things I wanted to share. One, so there's actually a draft that I put together, and Michael already reviewed and gave me some comments. I didn't share it here with the hackathon list after I posted, because I didn't want to kind of distract from people working on their projects. But if you do have some time now, I'd appreciate if you could take a quick look and review it. It covers the hackathon in general. It's the reason that, or what kind of the impetus for putting it together was because we're switching to this virtual format, and we're looking at the IETF, how we can, do a better job with online meetings in general, and the hackathon being kind of one example of something that that needs to be tailored to, perhaps run a little bit differently, as many of you have seen when it's in an online format. But the draft actually is meant to cover both, cover the hackathon in general, and to capture the things that that Barry and I have in our head from having run the hackathon over a number of years, and to get that down on paper or in a draft to kind of talk about aspects of the hackathon and how to run them in person and then also online. So just got the draft out in time for this IETF. It still needs a lot of work, but your review of it at any time and any feedback would be very welcome. In addition to that, let me just go back to the slides. So we finished up with the presentations. Before we leave, I do want to say thanks again to ICANN. ICANN has been the financial sponsor for the hackathon, the last several. They've already signed up to sponsor the next hackathon at IETF110. DevNet continues to be a supporter of the hackathon, and we still welcome additional sponsors of the hackathon. So the more the merrier. It's we really appreciate people helping us keep this event going and keeping it free and open to everyone. So at IETF 110, we already know it's going to be an online meeting. We know we'll do the hackathon to a large extent, very similar to what we did this time around, using probably very similar tools. Of course, we'll try to make incremental improvements. And oh, sorry, Justin, I see you just joined. If you want to, you're welcome to present. We'll go back to your, I can stop sharing if you want to just go ahead, jump on with your audio and video. We can jump to your presentation.
Yeah, thank you, Sean. Sorry for that.
Yeah, sure. Okay, I'll stop sharing, and glad you made it just in time.
Yeah, short. So can you see my slides?
Yes, sure can. Sorry.
Okay, thank you. So hi, everyone. Our team was working on the IPv6 IOM project, and on the agenda, we wanted to improve the kernel implementation. And actually, we already have sent a patch upstream a few months ago, and it still needs a little bit of work to get accepted, but it's definitely on the right track. Also, we wanted to update the VPP implementation for IOM because it was based on a very old version of the draft. And this task was already work in progress before the hackathon. And both the kernel and VPP implementations are based on the following draft. So the IOM IPv6 options and the IOM data, and of course on last version for both of them. And so after that, we wanted to test the interop between the kernel and VPP. And we also wanted to implement a new draft that could allow us to insert and remove extension headers and options in flight, which is currently forbidden by the RFC 8200. And we think that it could be valuable for IOM and solve some problems. So what got done? We had no time to test the interop, and anyway, the VPP implementation still needs some work to do so. All in all, implementations, so both for the kernel and VPP, are going well. And the implementation on the new draft was up and running, and it looks quite promising. And so here are a few results from the attribution option. This is the new draft. So basically, we have a bunch of options here, and each options that were inserted by a node on the path is linked to an attribution option. And here we want to remove this option, which is at the top of the stack. So it's allowed. And you can see on the right that this part has been removed and the padding and alignment is being taken into account. So what we learn, actually we have the IPv6 encapsulation solution, which is compliant with the RFC 8200, but it also brings several problems. The first one is, how do you choose the destination address? So the address of the exit of the tunnel for IOM, because you can configure it statically, but you never know if the routing changes or whatever. So it's hard to determine this address easily. Since you do encapsulation, you also have to do anonymous decapsulation, and that could potentially create a security hole, because you have to check that this decapsulation is something you want. And also you're not sure that the modified packet will take the same path as the original one. So those three reasons make it the IPv6 encapsulation solution hard to implement. So we believe that the new draft implementing the attribution option could be a solution for IOM, and it could be good to push it for working group adoption at 6 men. And we will also make a few suggestions to IPPM for the IPv6 IOM draft options. So team members, I worked with Tom on the kernel part, and first-timers, Mauricio and Jerome were involved on the VPP part. So I want to thank everyone involved in this project, and thank you all for attending this presentation.
And thank you, Justin, for the presentation. I'm glad you were
Thanks again, Charles.
Rejoin, and it worked out.
Yeah.
Okay. So with that, I'm just going to jump back to this kind of as a bit of a closing slide, but actually, you know, I hope many of you will join us for the next hackathon. There will be some questions related to the hackathon in the overall IETF 109 survey that goes out. It'd be great if you could provide feedback there, and you know, feedback as to ideas or ways we can, you know, what maybe didn't go as well that we can do better for 110, or new things for us to try. Very interested to hear that. We have some time now. If anyone has any thoughts, some of you shared as part of your presentation things that you found very helpful, like, you know, whether it was Gather or CodeEMD, or so that was great to see. But if anyone had anything else they wanted to share, happy to hear it now. You're also welcome to send me an email, send an email to the list, whatever works best for you. And feedback on the survey will help too. Okay, well, thank all of you for participating in the hackathon and for putting together the presentations and sharing them. I think it'll be a very valuable and thanks to the folks from Meteco helping me out along the way as we were trying to get all this working. I think it worked out pretty well. So yeah, rest up over the weekend and hope your IETF week goes very well also. Thanks again, everyone. Good night, or enjoy the rest of your day, depending on where you're at.
Charles, thanks.
Thank you. Bye.